The last topic in section 1.5 on inequalities is compound inequalities. These are the inequalities that give us the solutions that we saw where x is between two numbers. It doesn't involve infinity. So when we look at the first one, the idea is to have an x in the middle and to our left endpoint and right endpoint on either end. So we have negative 4x plus 1 in the middle. So what do you think we need to do to start getting just an x in the middle? You're right. We want to subtract 1 from all three parts. So negative 3 minus 1 is negative 4. And then we have our negative 4x in the middle. And then we have 16, right? What do you think the next step is? You're absolutely right. We're going to divide by negative 4. And what does that mean? What's the extra thought here? We have to reverse our inequality sign. Whoops, and I didn't do it, did I? Let's do it. Reverse the inequality sign. And 16 divided by negative 4. Okay, so we have 1 greater than x greater than negative 4. Now, that's not how we write in intervals. Intervals go low to high, left to right, just like the number line. Lower numbers on the left. So we've got to flip that thing over. So negative 4 is less than x, and x is less than 1. Now we're ready to write our set notation, the set of all x, such that negative 4 less than x less than 1. That describes all the x's in our solution set. They're numbers between negative 4 and 1, but not equal to negative 4 or 1. We can draw our number line. We have negative 4 on the left. We have 1 on the right. It's an open interval. And everything in between. And then from here, look, we can get the interval notation directly from that. Parentheses, negative 4, comma 1, close parentheses. Simple. A to B, open interval. All right, let's try another one. This one has fractions. So first thing I'm going to do, it's a choice, but I like to get rid of the fractions. So I'm going to multiply all three parts by the LCD of all the denominators, which would be 6, yes. So 6 times 1/3, 6 times x plus 1 over 2, and 6 times 2/3. So 6 times 1/3 is 2. 2 goes into 6 3 times, so I'll have 3 times x plus 1 left in the middle. And that's less than or equal to 3 goes into 6 2 times 2 is 4. This looks a little easier to work with for me. So 2 is less than, let's distribute, 3x plus 3 less than or equal to 4. Now we're ready to start isolating an x in the middle. First thing, subtract 3. So we have negative 1 less than 3x less than or equal to positive 1. Yes, divide by 3. Negative 1/3 less than 3x over 3 less than or equal to 1/3. So we've ended up with negative 1/3 less than x less than or equal to 1/3. Did we divide by a negative? Nope, didn't have to worry about reversing the sign. Okay, set notation, super easy. The set of all x such that, copy this right in there. Negative 1/3 less than x less than or equal to 1/3. We might want to do our graph next. You don't have to. Order doesn't matter on this. 1/3. That was negative 1/3. That's 1/3. We have a bracket here, parentheses there, and we'll shade everything in between. So now for the interval notation, it's super easy. Parentheses, negative 1/3, comma, 1/3, bracket. All right, our last example, we do have a fraction again. There's only one denominator. So I'm going to multiply everything by that denominator to clear it out, which is 2, right? All right, so we have negative 2 less than or equal to, the 2's cancel, 3 minus 5x less than or equal to 18. So what's our first thing? Subtract 3. Minus 3, minus 3, minus 3. So we have negative 5 less than or equal to negative 5x less than or equal to 15. And then divide by negative 5 and reverse the inequality. Yes. So we get what? Positive 1 greater than or equal to x greater than or equal to negative 3. Again, we have that situation. Can we see it? Let's see what I've done here. There we go. We have that situation where it's not in the correct, we don't have low to high, we have high to low. That's incorrect. So let's switch places. It should be negative 3 is less than or equal to x, which is less than or equal to 1. That's what this says, but says it correctly, low to high. So we have the set of all x such that x is greater than or equal to negative 3, but less than or equal to 1. On the graph, we're going to have brackets at both places because they're both or equal to's. And now our interval notation comes right off the graph.